Welcome to Sinter production, development and testing facilities in Ljubljana. How many years, decades does it take to perfect a craft? At Sinter, we've been at it for almost 60 years, yet we still learn, develop and strive every single day to achieve the optimum in braking performance. It all began in 1969, when the Krapeš brothers built on modern principles and poured countless hours of work to establish Sinter as a supplier of brake pads. Decades of innovations followed as they pursued technological breakthroughs. Early 70s were right around the corner, and Sinter developed the first disc brake pad in the former Yugoslavia. In 1989, Sinter became one of the first manufacturers in EU to develop an asbestos-free brake pad. Even today, the company remains family-owned. The younger Krapeš generation puts an emphasis on sustainability, cutting-edge R&D, and product range flexibility. Racing has always been close to our heart, as our products continue to prove their worth in races. We are sponsors of prominent teams in the Mountain Bike World Cup and the Pro Peloton. Now follow me and let's explore the making of a Sinter brake pad together. It all begins here, in the heart of our company, our mixing room, where aramid fibers, ceramics, carbon and resins are precisely mixed to form any one of our different friction compounds. The mixing room might not look like much, but this is where the magic happens. Choosing the type and parts of ingredients determines whether a brake pad performs or not.
Just like baking bread, the result would be as bad as putting flour in the oven before the dough is ready. Here, the sequence is what gives the brake pad the exact characteristics it needs: strength, durability, and performance.
We swear by organic compounds as they do not transfer heat into the caliper as readily as sintered pads. Energy is retained in the pad and rotor that ensures a more stable, predictable, and safe braking system. Our friction material needs a strong base in the form of a metal backing plate, which are stamped right here. But before the backing plate can accept the friction material, it must first be prepped. This involves sanding, deburring, degreasing, and finally applying adhesive, which will create a strong bond between the friction material and the metal backing plate.
The friction compound is formed into blocks, which are waiting to be hot pressed on the backing plate. Molds are used to precisely fixate the backing plate in relation to the friction compound as it is being pressed. Our press squeezes with 100 tons of pressure. That's like stacking 20 elephants on top of each other. We make 20 to 40 brake pads at once, so that's about 3 to 5 tons of pressure on each brake pad. Just one pad gets more pressure than a full-size loaded van rolling over it. After this step, we can see that this half product is starting to resemble a brake pad in the rough. You can see just how much the friction compound gets compressed in these giant presses. The brake pads are loaded into baskets and placed into the oven in batches. The compound may seem solid now, but it needs further heat treatment to perform well during hard braking. The oven is closed and a fitting heat cycle program for the specific compound is selected.
The pads are then cured in the oven. That fully cures the resins inside the friction material, which is then ready to perform and maintain a stable coefficient of friction in a wide temperature range.
Another cleaning process follows, where impurities from the curing are removed from the pads. The surface of the friction material is yet much too uneven. The brake pads are loaded into the grinding machine and machined to size.
We utilize powder coating to protect our brake pads from corrosion, as the coating is extremely durable. Today, we're making the 2032 compound, which is marked by the green color.
The painting process starts by placing the pads on the conveyor belt. An automated nozzle distributes the powdered paint between the pads, which ensures an even coating. The second phase of the procedure is yet another curing process to achieve the final finish and hardness of the paint. The thickness of the coating is measured with a gauge on each batch of pads.
Finally, the last two steps of the production process, that is marking and packaging. After this, your brake pads are ready for delivery. That was a tour of the production facilities, and now let's visit the R&D department.
Welcome to the Sinter testing laboratory. Here you can see Kraus RVS testing machine, which is used for testing and developing brake pads. We use this machine each time new batch of friction material is mixed in order to check all the properties of the material: wear, noise, friction coefficient, and some other parameters. Here we can measure temperature, pressure, speed, and acceleration. This is our brake testing machine, which was developed by Sinter. It mimics the layout of the bike. On the back side you have flywheels for setting up weight, and here is brake disc, caliper, brake lever, and pump, which is pushed by the actuator. Here you can mimic rain, so you put water on the brake disc, paddles, and record noise, deceleration, measure wear, and basically gather the information from telemetry on the actual bike, and then mimic that behavior indefinitely to make development and testing shorter, reliable, and more swift. The biggest advantage of Sinter is that we do everything in-house: development, mixing of friction material, production, and testing. That's why we're really fast and responsive. The brake pad is made from backing plate and friction material, and what's important is wear, noise, friction coefficient, consistency, and steady friction coefficient, which means that the brake works the same under all circumstances.
And if that weren't enough, our pads have performed well in many tests conducted by various magazines. For example, this one done by Enduro magazine. I hope this video helped you to grasp our manufacturing procedure, our design goals, and at the end of the day, our philosophy. Thank you for your attention. Stop safely, stop with Sinter.